2.8 application is going to ask us to basically spend some time making some other regression models, quadratic and exponential, and then comparing the two to see which one might be better for a given set of data. So the title of this is How Does Life Insurance Work? It says, how do insurance companies decide how much to charge for life insurance? They rely on a staff of highly trained actuaries, which are people with expertise in probability, statistics, and advanced mathematics, to determine premiums. If someone wants to buy life insurance, the premium will depend on the type and amount of the policy, as well as on personal characteristics like age, gender, and health status. This table shows monthly premiums in dollars for a 10-year term life insurance policy worth $1 million for people of various ages and years. And obviously, the older that a person gets, the higher the premium is, because they realize you're getting closer to death. And so they are aware of the fact that, they're going to have to fork over some money. So that's just kind of how it goes. So they're going to ask us first to calculate a quadratic model. So again, we're going to go to our applets, and we are going to click on to quantitative, and we're going to get this table again. Again, our explanatory and our response variables. Explanatory is what is causing what. And here, the premiums are going up because what's causing them to go up is the age of the person, okay? So I've already kind of put in this data one time already, and this is going to be the same data we're going to plug in twice. I'll do that in a separate table. And I'm going to begin the analysis. This time, it's already been calculated, or it says quadratic, so I'm just going to click on Calculate Other Regression Model, and it's going to do it in quadratic form. So if it's in quadratic form, it's going to look like half a parabola. Okay, the other half would be over here somewhere, okay, on this side. So there's your parabola right there, and I've got my model right here. So I'm going to go ahead and write this model in. Let me see if I can copy and paste it. Let's see. Copy. And I'll use a text box and see if I can just paste it in there. So I don't have to copy it. And it worked. Oh, kind of. Not exactly. Here, I'll tell you what. I'll at least leave it right there for a moment so I can write it in. So y hat is equal to 674.95 minus 191x plus 0.379x cubed. Okay, so there it is. Do not get rid of, you might just want to open the window again. Do not get rid of the scatter plot. You're going to need that for question number 3. Okay, so now I'm going to go, and you can see I've got several applets open. So this was the first one that I just calculated the quadratic. So now I've opened it a second time, and I just copy and pasted the same data, and I'm going to begin the analysis, but this time I'm going to click on exponential model and calculate that one. And so you get this, and we're going to be paying attention to this residual model scatter plot. So don't get rid of them. Open them up in two separate windows. All right, so here is my exponential model. So let me do the same thing I did a minute ago. I'll just go ahead and put it in here, even though I'm going to have to. This particular thing on Scribbler does not allow me to use exponents. So it looks like it's an x, but it really should be an exponent. So 0.939 times 1.09 to the power of x. So it's the exponent up there. Okay, so now I've got my two models. On the actual lesson app, it asks you to draw those residual scatter plots, but I just figured as long as you have them open, you can kind of compare the two. So I'm going to look at each one, and I might even, let's see if we can take a screenshot. I might even be able to do that where I can take a screenshot. I'm going to remember how to do it. Nope. I don't remember how to do it. So I'm going to compare for a moment, okay? So I'm going to look at, this is the residual scatter plot for the quadratic model. So what I want you to pay attention to is where the residual line is. This is kind of like the average residual, okay? And then look to see how close to that line the points are. You can probably see they're not super close. This one is. These all seem to have a little bit, that one has a very far away residual, okay? And then let's look at the one for the exponential model. So obviously you can see this exponential model are a lot more, the scatter plot shows that the points are a lot closer. The residuals are a lot less, okay? So that means that the exponential model is more appropriate as a model to represent this data. And you can even see up here, the line of regression, those dots follow really closely. Whereas over here, they're slightly off. They're not horrible, but they're slightly off, okay? And clearly the residuals are less because there's 1, 2, 3, 4 points that are closer rather than just maybe this 1 point right here, okay? So this is quadratic, this is exponential. And so the exponential is going to be more of an appropriate model. So that's what I'm going to write in here. I'm going to say because the residual plot for the exponential model has smaller residuals, meaning the data are not very far away. Oops. Smaller residuals. It is more appropriate for this data. Okay, so better than the exponential. And again, it's a result of how close the points are to that residual, okay? These residuals are a little farther away on the quadratic model than they are on the exponential model. So the exponential model is the better of the two. And then lastly, using your chosen model, calculate and interpret the residual for the 65-year-old. So I'm going to take my exponential model, since this is the one I thought was more appropriate, and for the number of years, I'm going to put in 65. So y hat equals 0.939 times 1.09 raised to the power of 65. So I'm going to get out my calculator. I'm going to do the exponent first. So 1.09, on the calculator on my computer, I push this button. Yours will be that caret button. Okay, so raising that to the power of 65, I get this, and then I'm going to multiply by 0.939, and I get roughly $254.32. $254.32. So to interpret this, I just simply need to mention that the premium for a 65-year-old person oh, I'm sorry. Hold on. I got more work to do here than I thought. That is just this is the predicted amount. Okay, this is the predicted based upon the exponential model. They're asking us to calculate the residual. So the residual is the difference between what the table says a 65-year-old would pay and what the predicted amount is. So if you look up here for a 65-year-old, it says it should be 257. So I'm going to say the residual is going to be found by doing 257 minus 254.32. That's going to give me that it's $2.68. So the predicted value, okay, and that's what we will say. The premium for a 65-year-old is $2.68 greater than the expected, or I could say the predicted, remember? Than the predicted based on the exponential model. Okay, so to sum it up, they're saying that the predicted line, which is this regression line, the predicted value is 254.32, but in reality, a 65-year-old is really being charged 257. So the 65-year-old is actually paying $2.68 greater than the predicted model. And again, the model is based off of an exponential model, not quadratic for this particular example. Okay, so that should get you started on the homework for homework 2.8. I believe it's quite a long homework, but it's really just 3 problems. You're being asked to calculate the different models. I believe you're being asked to sketch in the different scatter plots as well, so that way you can accurately compare which one is the better model. So hopefully that'll get you started.